Okay, so I think we can start. Thank you very much for coming to this conference. First of all, I'm going to introduce to you Mr. Anne-Lykke Jacobsen. Well, he's Professor of Translation and Translation Technology at the Copenhagen Business School. He was there an assistant, then an associate professor of English literature, but first of all in Copenhagen University from 1972 to 1985. And then, after joining the Copenhagen Business School, his interest in translation became more oriented towards professional and business communication. And then in the 90s, from 1990 to 1994, he coordinated a major research project on translating specific purpose language texts. Then afterwards, he invented a keylog software program, Translog, and the first version of this software was developed in 1995. This was due to this growing interest in translation processes and methods. Subsequent versions of this program have been very important, a key technology in a wide range of experiments, including two European projects, the I2IT project from 2006 to 2009 and the CASMACAT project from 2011 to 2014. It is also worth noting that he has established the CRITT, which is the Center for Research and Innovation in Translation and Translation Technology. And, well, his main lines of research have been the development and the exploitation of a methodology for translation process research using the keylogging and eye tracking. He has also published many articles, chapters and books in these fields. So I would like to thank you very much again for being here today, and I am sure we are going to learn a lot from you. Thank you.
Thank you very much, Lucia. Thank you for coming, and I understand that there are people out there also following this, so welcome to everybody. And thank you for everything you said, Lucia, but all of that is way in the past. And I am really honored to be here still and to be allowed to speak to you. I hope that I may generate a little interest, if you don't have it already, in what we call translation process research. And this is what I'll be trying to give you an overview of today. And what I'll be talking about then is translation process research, TPR for short, we call it, how it developed from Think Aloud to keylogging and eye tracking, and I may comment on where I think this may be going also. I'll talk about methodology, the research tools and the research designs that we have mainly used, how data representation is done from the recordings that we get, the keylog and the eye track recordings, or the qualitative data that we get from interviews, from questionnaires, from retrospective interviews also. And then finally I'll try to, well, I'll give you, I hope there's time to give you a little demonstration, a little illustration of what the data looks like, the dynamic data looks like, but I'll have to then leave the presentation and go into the software proper that we're using to give you that demonstration. And then finally, I'm trying to give you the scientific context, as I see it, of what we're into. So the main idea was, after we'd been studying texts for so long, looking at the source text and the target text and comparing them and contrasting them, I thought it would be interesting, and I was not the only one, many people thought it would be interesting to get to know more about how these texts came into existence, what were the processes, what were the cognitive processes mainly, whereby they were made. And the idea that I got first was to look at how they were typed, how the keystrokes were made in time. And this led to this focus on what we call micro-behavioral processes. So we're simply starting from observing a very selective portion of a translator's behavior. We think it's an important selection, but it's a very selective, if you think of all the things that go on inside a translator, or an interpreter for that matter, and you select only what the fingers are doing and what the eyes are doing, then you are extracting a very small portion of behavior and hoping then to make inferences from that about the cognitive processes that are taking place. So that's what I mean by the selective focus on keystrokes and gaze behavior. The reason for focusing so selectively is, of course, that we think they are closely connected with comprehension in the case of eye movements. That's what we thought at first, but the eyes do much more than read source text and comprehend source text. They monitor the production very extensively also. What we can see also is something that I've been very interested in finding out about. In the old days, we talked about translation units. We still do that, but we're more and more interested in cognitive processing units. So why is it that translators don't write at the same speed? Why is it that interpreters don't speak at the same speed always? Why is it that production seems to be chopped up into smaller portions, chunks, segments, whatever they're called? Well, because it appears that the human brain works with text in this manner by chopping up a long string of information into smaller portions. Now, what were the available methodologies then back in the 1980s when interest in cognitive processing started? There was introspection. We still have that. We look inside ourselves. We know from inside how we do it, how we translate, how we interpret. So there's memory also. We know what we can do. We know the limits of our own knowledge. And we have this subjective experience for which there is no real replacement. We depend very much on what we know from inside, from introspection, because this is what creates our intuition. And this is where research begins, with an intuition. We have an intuition that things may be one way or the other. Then we create our hypothesis, and then we go into the world and study empirically to find support for what started as an intuition. There's observation, this outside view, where we observe behavior. And I already talked about the selective way in which we look at behavior. We can do video or audio recording. We can do think aloud, or we could do. And this was what was done mostly in the 1980s. It was a revolution when Simon and Erickson published an article first in 1980, and then in 1984 brought out the first version of the full book, which was the Bible of Think Aloud, called Verbal Protocols. And a revised edition came out in 1993, but that was the Bible. What puzzled me, because I always had strange sentiments about Think Aloud, sentiments of not being quite good enough to understand what was going on in Think Aloud, because a lot of it sounded like explanations, but we were told by Erickson and Simon to treat verbalization as data. So how do you treat verbalization as data? Well, you invent a lot of categories and you try to analyze those categories. But verbalization is very seductive, and I've always felt that it was extremely difficult to distinguish between what appeared as explanations and what I had to treat as data, and then how would I do this. So in addition to that, it was a very laborious process, because you would want to transcribe everything into a think aloud protocol. You would have to make decisions about what would count as data and what wouldn't. So there were all of these categorization, classification, taxonomy issues involved. How would you annotate all of this data? And Ericsson and Simon were aware of these difficulties and countered them in the famous introduction they wrote to the revised edition in 1993. But they had been aware of this all along, in a way, claiming centrally that to the extent that information was available in verbal form in short-term memory, it could be verbalized without any effect on the primary process. And this is the issue of reactivity that I mentioned, which has been the really crucial thing about the Think Aloud method. Because you have Vygotsky on one hand saying that verbalization is a learning method, so that there is necessarily reactivity. There is a reaction from the method that you use on what happens to your cognition. So there is necessarily reactivity, he would say. And Ericsson and Simon were saying the opposite. There is no reactivity. You can verbalize without any cost, without any effect on the primary process that you want to study. And this, I thought, intuitively, if you like, was so wonderfully counterintuitive that I thought I would have to try and find a method of investigating this. And this was really how I came upon the idea of trying to get harder data, as I call it, from a computer by logging the keystrokes, and not to invalidate the Think Aloud method, but to complement the Think Aloud method so that we would have data from two different sources. And this would make us, this would put us in a position where we could triangulate two data sets deriving from one event, one translation event, where a person translated and thought aloud, verbalized the thinking. So we would record both what was done across the keyboard and still make a note of what was spoken. This is just an overview of some of the processes that were identified on the basis of Think Aloud. And wonderful work was done, I have to say, especially by Hans Krings, who did his Habilitation in the 1990s, but it was translated and came out only 5 years later. And this is the version, the only version published. So that is the one that people know. Repairing Texts, it's called. It came out in 2001. And he identified more than 200 different processes relating to source text, reading, to, he did machine translation also. So some of the processes were obviously related to working with machine translated text, evaluating what it was like, and relating it back to the probable source text. So there were processes that were different from when you were reading simple source text. He was interested in knowing also about phases and the timing of these different processes that were going on when text was being typed, not typed but written in hand in his experiments. And so to get the timing right, he was using different colored pencils and asking his students to, when he rang the bell, they would have to shift from using a red pencil to a blue pencil and so on, and then he would know what the time sequence was of the changes made. And obviously this is very far from the accuracy that we were able to obtain when we started using the keylog program, where we would get an accuracy of about 1 millisecond and know exactly when a key was struck. And if you want to know about cognitive processes, I would argue that you need very exact timing, because the brain works very quickly, and the mind coming from our mental consciousness coming from the brain works very quickly also. So I concluded then that verbal data was fascinating, but it was also seductive and difficult, and I wanted something harder in my life, so that's how I invented Translog, which came out in a terribly looking DOS version back in 1995. You're not old enough to remember, so most of you, what screens looked like in those days and what programming was like, but I won't go into that. The first Windows version was produced in 1999 when we were all anticipating the new millennium. So we call this the millennium version of Translog, and that was in old Windows 3.1, which is now also completely obsolete. So what Translog did and still does essentially is to record exactly what key was struck when, with an accuracy of about a millisecond. So you get very simple data. You get keystrokes in time, and then the software calculates the intervals. And you can subcategorize the keystrokes into the ones that help produce the text, the ones that eliminate text, and then there are a number of cursor navigation keystrokes also. But you get very interested not just in what gets typed, but also the timing of how it gets typed, because these pauses seem to intuitively correlate with processing. So we halt, we have a pause when we come up against a difficulty. So I have to go out of the program, and let me try and see if I can get this to run. And in a way, I'm asking you only to look at the keystrokes, but it has some gaze data also. So this is the translation just of 4 sentences of a text about a killer nurse, translated into German. So there's some reading to begin with of the headline. Nothing gets written. Now something gets written. Krankenschwester. Okay, pause. And then another. No, okay. Here's a better solution. Is that okay? Evaluation. No, we'll change it a little bit. Okay, here's a better one. So you see how there's a cascade, if you like, of suggestions coming up. And one of the things that we observe, die Krankenschwester, and now, oops, is Colin a girl's name? Because obviously Krankenschwester can only be female. So, oops, what do we do? Read on. I need to find a contextual clue somewhere. So you need to move on and find that clue so that you can change it. Okay, how do I change it then? Yeah, Krankenpfleger. But then there's a syntactic problem because I have to get im Krankenhaus Angestellte in, and so on. You get the idea. And you probably have much better interpretations of what goes on than I have. Just a point of information, when you see something red, these are gaze samples from the right eye, and from the left eye, sorry, and green from the right eye. And the way we designed this was that, contrary to the way most industrial software represents fixations, they are calculated fixations. We decided that we would have the program build fixations from individual samples so that you get a stronger impression of the dynamic and organic way in which we think the brain is processing this information. So we have, this was recorded this was a recording at 300 hertz, which means that there are 300 little pictures being taken of the eye every second. And there are 300 samples then, as we say, per second. And they build these fixations if they are recorded from close enough positions. So, this is what you saw. You saw something being typed. You saw also, as you can see here, that the gaze is monitoring the typing. So we're not just reading. In this obviously, if you have a person who is a perfect touch typist, that person will not need to look at what is being typed. But this is what we found, that even if people are good touch typists, they will still monitor the typing, especially if they are in a second phase of revision, for instance, or you saw this cascading effect that I called it, where lebenslang, lebenslänglich, and all of that was being revised. You typically get an intensive monitoring activity going on with the eyes in what we call the target text area, the target text window. What we can do with the keystrokes is to pick the sequence of keystrokes. The program can calculate and recalculate the intervals between keystrokes very flexibly and very quickly. So if you are interested in minute things, minute details, you can get interval data between any two keystrokes, typically between maybe 80 milliseconds and 150 or something, depending on the speed that a person is capable of typing with. But most people, or for most research purposes, I should say, we don't need all of that information. So if we're interested in chunking in segments, we're often better off at a level, say, like about 1 second, perhaps. And what I've done here is to suggest that we have roughly 2-second intervals between segments. But if you look at the start, I've put one in blue, 1.530. That's not quite 2 seconds, you might say. Well, but there's no text production going on, you'll see, until you get down to the K. So I've said, here we have only one segment. There's some up and down movement of the arrow keys, but the segment proper begins with KR. Is KR a segment? Well, technically, mechanically, it ought to be, because just after KR, there's a long pause of 3.5, 3.6 seconds. So yeah, this is up to you. to then determine, would I insist mechanically that if there is a pause longer than 2 seconds, then that should initiate a new segment. What might influence your decision here is gaze information, but we can come back to that when I get to talking more about gaze information. But up here, I've provisionally said, no, KR is not really an independent segment, so it's Krankenschwester that was being processed. This is my claim. And you see, similarly in segment 4, 1.372 is not quite 2, but then there was a decision to delete lang, and if you add the next pause, you then get more than 2 before the segment begins with genuine text production. So this would be one way of trying to approach the idea of identifying processing units. But obviously here we are looking at output units, output segments, which come at the final end of processing, you might say. There's a lot that goes on before you process a segment of source text. The meaning that you construct from a segment of source text, I should say perhaps, and you try then to align it to some representation in the target text. And when you get to typing a verbal representation of your translation, you are really at the end of a long process. So this is how I see it, that segments based on keystrokes come at the tail end, as I've called it, of processing. And this is the same, you carry on. One of my PhD students from some years back decided to work with individually calculated segment boundary values on the premise that just as people are capable of running at different speeds, they are probably capable of processing at different speeds. So what she did was to look at overall task time for one of her participants in an experiment, and then she created a formula based on the overall task time, which differed, and then from that calculated what this particular person's most probable segment boundary value would be, and found very nice correlation by this method between segments identified in this manner and phrase structures based on grammatical analysis. My successor as director of the CRIT Center, Michael Kahl, has a background in computational linguistics. So he prefers to do it in this manner where the vertical black lines represent sentence boundaries, and then the orange and yellow and so on colored wavy representation indicates the duration of pauses. And as you can see, very often they coincide with sentence boundaries, except that in the third there's suddenly a peak in the middle. So there's something else going on that holds up production than sentence boundaries. And you all know what this can be. It's a translation hurdle of some kind. One study that I really like was done by the people you see there, Sini Imonen on the left, she's the one on the left, and her supervisor Jukka Mäkisalo from the University of Eastern Finland. So they did a study where they compared monolingual writing, meaning writing a text in Finnish. In this case, they were Finnish students asked to write a text in Finnish, and they compared this with translating a text into Finnish from English. So and looking at pauses and looking at keystroke intervals and speed. So what they found was basically this graph, which doesn't look like much, but I think is really interesting, because what it shows is that all the way from character down there at the bottom left on the x-axis, character, then syllable, then compound word. Compound word means the interval between the two constituents of a compound expression. And word and phrase, then subordinate clause, and then the two lines break. So the dotted line represents translation, and text production is the blue line. And what happens is that, and the differences don't look much, but they are actually statistically significant. At any level, the intervals between individual characters, between syllables, in translation are larger than in writing in the same language but monolingually. Why is this? The obvious explanation is that translation, which involves activation of two languages, of course, imposes an additional cognitive burden on the translator, making all the activities slower, but only up to the level of main clauses, because then it gets easier. And again, the explanation is very obvious, that the translator can take over the structure of the source text, doesn't need to engage in long-distance planning, for instance, of new text. Whereas if you are writing text in your native language, you need to plan ahead and think about what to do next, syntactically, but also content-wise. And this explains this nice little difference that I think they demonstrate beautifully. So we're getting to the end of the stuff about keylogging now. I think keylogging is still fine. And there are findings that we have claimed and that can be claimed, that we were able to identify translation phases very, very accurately, that there was an orientation phase, and the moment translation started and typing started, that was the beginning of the drafting phase. And once you got to the end and you put the first final stop of your drafting, that was the end of the drafting phase, and you could see visually how behavior then changed completely when you were in the final end revision stage. We were able to demonstrate the decelerating effect of think aloud by comparing translation with think aloud, with concurrent think aloud, and without think aloud. This is something that had been predicted by Eriksson and Simon, and that Hans Krings had also found, so this was not surprising, that the delay is about 25% typically if you ask participants to think aloud concurrently with translating. But what had not been demonstrated was that it also has a degenerative effect on segmentation, that if you ask a translator to think aloud while doing the translation is broken up into smaller units. It's as if you are at a lower level of training. Suddenly your behavior degenerates a little bit, which makes very good sense to me, because if you're asked to multitask in a way, then it will have an effect on the quality of the one of the activities, the translation here. We demonstrated facilitation effects simply by being able to show that once you get into a text, segments get longer, you work faster. You could compare segmentation in the first half of a translation with the second half of the translation, and you would find that they would differ, and that facilitation would be observable. And we tended to experiment a lot with two groups of participants, experienced and inexperienced, students and professionals, or whatever we call them. Very crude categorization we have found later, but segmentation patterns, translation speed, and typical behavior in the three phases could be seen to be fairly general. For instance, with respect to behavior in the three phases, what we found was that professionals, well, neither students or professionals spent a lot of time in initial orientation. We had one participant who read the whole text, for instance, before beginning to translate, and this is the recommendation, of course, that you may have heard many times and that many teachers produce. But the only participant in our experiments who actually did that was somebody who was a translation teacher herself. So most participants will, whether they are professionals or students, will read a little, and then they know enough to begin. And of course, if you are an interpreter, for instance, you don't always know what will be spoken later. So you've got to be there right from the beginning and straight on. You've got to be able to produce something. And this is how translators work also, typically. What we found then was that professionals are capable of drafting the text more quickly than non-professionals, but then they don't win us the time that you might expect, because they are much more careful revisers also than less experienced translators. So basically, we recognize this rhythm of production, which we assume reflects cognitive rhythm. We identify processing units, but from the output perspective, as I said, and we find fairly good correlation between processing units and grammatical units, typically at the phrase level. And pause distribution is systematically correlated with linguistic units at all levels, yes. Pause distribution at any level, as we saw in the experiment done, the results from the experiment done by Immonen and Mekesalo. But, obviously, we had problems, especially with how to interpret what was going on in those fantastic and fascinating intervals. We didn't really know whether participants were reading source text, whether they were reading their own target text, whether they were not doing anything or going to the fridge or pausing irrelevantly, as we said, and that's why we thought it would be fantastic to know more about what a translator was doing by knowing what the eyes were doing during these pauses, and that's how we bought our first eye tracker back in 2006. So, in the experiments, these were the, from then on, these were the typical research tools and the typical design elements that we applied in our experiments. So there would be questionnaires. Sometimes there would be an emphasis on what we call continuous tasks. And by continuous tasks, I mean, and this is differential from what is the case in psycholinguistics experiments typically. In psycholinguistics, there's a strong emphasis on control. So a translation experiment there might be a display of a source text word and then two candidates as translations, and you would say which one is an acceptable translation. And most of our participants, being translators, said this is not translation. They would want something that they felt was a more naturalistic simulation of a real translation situation. So we opted for what we call continuous tasks, meaning, and there were technical reasons for why we ended up mostly using texts that were only about 140, 150 words long, because that was how much we could put in the screen, the window on our screen, so that we could also have fairly accurate gaze data. So we needed to use Tahoma 20 pitch, for those of you who are into the technicalities, and double line spacing. And that was the practical reason why we ended up with defining continuous texts or continuous tasks as tasks with texts of about 140, 150 words. So we would use Translog for keylogging, and we would use an eye tracker. And after 2006, when we had combined, when we had added eye tracking into Translog, not so that Translog does the eye tracking. There's an eye tracker that does the eye tracking, but the data is sent into Translog so that we get both the keylog data and the gaze data into one software. And then we used, instead of concurrent verbalization, concurrent think aloud, we decided to go for what we called cued retrospection, or immediate cued retrospection. That is, once a translation had been done by a participant, we would replay the data with the keystrokes and the gaze data, and stop it at intervals, either at intervals that we were particularly interested in getting information about, or we would have the participant stop the replay at points the participant found were particularly interesting, and have the participant retrospectively comment on this. And we found that we got wonderfully rich information in this manner, because seeing the replay seemed to activate very detailed memory of what had been going on in the translator's mind at the time. This kind of information, again, is data that you have to be very treat with a lot of care, because some participants like to please the experimenter, and they will talk very volubly about all the wonderful activity that was going on at the time, and some highly expert translators will say very little. And there are all kinds of social interaction phenomena going on, all kinds of psychological phenomena, face-saving phenomena and so on going on that one has to be aware of in these situations. So data of this kind, again, is not something that comes straight out of the mind. You don't know exactly. You've got to be very strongly aware of the socio and psychological interplay between the experimenter and the participant in the experiment. So the tasks that we typically had were translation in both directions. And we, coming from a small country like Denmark, you have to do a lot of inverse translation. So nobody outside Denmark knows Danish well enough to be able to translate from Danish into English, for instance. So there's a lot, our translators, and I think interpreters also, do a lot of inverse directed translation and interpreting. So we did that. We were also interested in sight translation. We were interested even in speaking a text out loud also. And post-editing, machine translation, this is a specialty that we got interested in mainly because we had some very strong people who worked with machine translation and had developed machine translation. And post-editing, of course, is winning the day, it seems, in industrial translation. Around the world, this is how more and more professional translation is done. And participants, materials, conditions, you know all about that. So we got to gaze data. And I have already replayed this, so I won't do it now. This is how data was typically represented, how the K, I don't know if you can really see that, but you can see that there's an XML representation with an exact time of day for each sample. And most of these would be gaze data, so they begin with I time in the left column, but then suddenly you get key height, and the key value was the K. This is the K in Krankenschwester. What you know there is that K was typed and it's surrounded by Win1, which means that the gaze was still in the source text. So the I and the fingers had been placed on the keyboard in position so that the K and the R could be typed without the gaze having to go down. But if you look ahead in the sample survey in the XML, you can see that the gaze goes down just as the R is being typed. So, and then there was this pause afterwards, which is why I thought that this could be regarded as a kind of stumbling introduction rather than a separate section. And we already looked at this information here. I've frozen some of the pictures, and you can see the information there about what was read. So what was read was the headline. You can also see that the representation of the gaze data is skewed to the right. So you should pull it to the left, which is calibration that was slightly wrong in this recording. So to get what the gaze data really represent, what was actually read, you would have to move them all to the left in this case. This varies from recording to recording. And obviously, if you have perfect calibration, you get perfect representation also. If you have poor calibration, as in this case, then you have to shift the representation to get the representation mapped to the linguistic information on the screen properly. And this is where the first letters were written, the KR that you saw. So you see here the circles, meaning fixations in the headline, must have been on killer nurse, because this is Krankenschwester and killer nurse. So if you go back up, you can see that these are really the leftmost fixations in this particular recording. The representation, this is where the letter K, it's the same as the one you saw before, in the middle of Win1 samples, and Win1 is there at the top, but then Win2, just as the R gets typed, the gaze shifts to window 2, which is the target window. So, what more is it that we learn from recording and analyzing gaze data? We thought initially that what we would get to know about was comprehension. What is it that a translator understands from the source text as a basis for producing the translation? But we get to know much more, as you can see, and I've listed what we get to know here. We get to know what portion of the text is inspected prior to translation. Sometimes you can see that the reading goes on a little bit longer than to where you have what I've called a translatable unit. But most translators will only read as far as to where they know they have a translatable unit. And I will show you this later. This is very typical of the translation that you saw, this translator stops whenever there is a translatable unit. This is a dangerous strategy, you might say, because something may turn up then later. If you've only read enough to have a translatable unit, then there may be something that forces you to completely reformulate the sentence, especially if you're translating into German. So it's a dangerous strategy, and nevertheless, this is the strategy adopted because shifting around the syntax is only necessary relatively rarely, apparently, or at least this particular translator has made a calculation, perhaps unconsciously, that this strategy of sparse forward reading, as I call it, you only read what is necessary to have a translatable unit, that it pays off in the long run, even if sometimes you have to change the solution that you came up with on the basis of the first segments. So what you see also here is, or what you want to know, I've put this as question marks, but the answer is really that this is what you get. So how is source text reading coordinated with TT typing? You can see that very clearly. What are the eyes looking at when there is no keyboard activity? That is what we primarily wanted to know. We know this. Are reading and writing activities sequential, overlapping, or concurrent? Well, we've seen that the eyes can be in one window and typing can go on in the other. So it is possible to multitask. This does not mean necessarily that processing is parallel, as the saying is, that we are saying how the brain is organized and how it processes information. What we're saying is merely that it is possible to somehow attend to two activities in parallel. And how different is translational reading from ordinary reading? It's very different, we found, and we were able to demonstrate this. So here are a few generalizations that we came up with, that reading is highly dependent on reading purpose. That if we found that if we said to participants in an experiment, we would like you to read this text, and then afterwards we will ask you some questions about it. We call this reading for comprehension. They would read in one way. If we said, we would like you to read this text, and then when you've done that, we're going to ask you to translate it. We didn't ask them to translate it, but we just gave them a different instruction, and the reading was completely different again. So reading depends very much on the purpose for which you read. With the instruction that they would be asked to translate later, they would pre-translate and begin to focus much more intensely on certain portions of the text. And what we found also in this experiment that we published in, the results of which we published in 2008, was that if you have a third text, as we said, or if you have two texts, or perhaps a third, meaning the keyboard, then you get a vast increase in visual attention, mainly because you have to coordinate two texts, the source text and the target text, and you have to shift between the two very frequently. So this is something technical that I will go over very quickly, but gaze-to-word mapping was completely critical for us in 2006 when we tried to integrate eye tracking data into our analyses. Because an eye tracker records what the eye is looking at on the screen, in the sense that what pixel the eye is looking at. So it returns coordinate XY values of where the eye was looking. It doesn't know what's on the screen, and we wanted our software to know what was on the screen, what word was being looked at. So we had to map the XY coordinates that we got from the eye tracker to what we knew was on the screen. We had to tell the software, word 17 is at this location on the screen. If there's a gaze in that location, then we map it to the word. So this is gaze to word mapping. And then we had to build these samples. We got 300 every second, and we built them into fixations if there was a fixation. And this is how the eye reads. You know that there are about 4 fixations in reading every second, and between them there are these jumps called saccades. And this is very reminiscent of keystrokes in a way, that you have fixation, jump, fixation, jump, fixation, jump, except that in reading they're very short pauses. Saccades typically last only 20 to 30 milliseconds, and nothing is seen during saccades, but they are then followed by fixations, typically about 250 milliseconds or 230 milliseconds. So we build samples into fixations and get an idea of reading in this way. And I apologize for having to move a little bit quickly across this, because I want to show you something more interesting, I think, at the end. So we map fixations to words, basically, and then our idea is that we want to move upwards from this very basic behavioral data that we get, which is really pre-linguistic. It's finger movements and it's eye movements, but we connect them to linguistic information and hope then to make inferences from there about what goes on in the mind. And so let me try to show you just sentence 4, if I can. Maybe I'll open it. Yeah, I can do. No, I'll open the so that you can see it from inside the program. So here's the source text, and the representation is a little bit different from what I expected. But we will run through this very quickly. We can speed up the replay because I want to get to sentence 4. So we'll run it at 5 times the speed. This is what you've seen, except that now it's 5 times faster. See, now we're already into gestern. Maybe I should just go back. And then what we can do is to run it very slowly at 1/5 of the speed. And you can then see we have 2 options, or we have many options here, but one is refresh. Refresh means that once there's been a fixation and you get a new fixation, then the old fixation disappears. But I'm going to change to collect, which means that the fixations will stay on screen. And now it's going to be slow. So you start down here, go up and read. Yesterday, the representation, I can't do it inside the program because the video changes this completely. So let me give this up, and I hadn't anticipated that the representation would be different. So let's see if I can show this to you instead. This is normal speed. The normal speed read, but this is only sentence 4, the one beginning yesterday. He was found guilty. And you see, gestern was written immediately. There was a translatable unit. Gestern, wurde er. Okay, no, let me try something else. Because what happened, don't know if you saw this, because it happened very quickly. So I go back and then I can't. What I want you to look at is that first, yesterday is translated into gestern very quickly, seen as a translatable unit. He was found guilty of 4 counts of murder, but the sparse forward reading means that only the text up until murder has been read. Then there's a shock. What happens when following a long trial is read? That was not anticipated, and you see what happens in reaction to that reading. See, this is what happens when you're poor and you can't buy the full version. Gestern wurde er, and then did you see that there were 2 fixations on following a long trial? So what happens if you play, I wanted to play this slowly because you can see it's read, but the translation continues until des more de, the S never gets typed, but so there's a kind of delay where what has been programmed to be typed continues to be typed even if the sequence that will change everything has already been read. So this is then the first suggestion is to translate following with in Folge, which is something that is cognitively very interesting also because it supports the literality hypothesis that the first impulse is to do a literal translation. And in Folge sounds a bit like following, and then you see this is followed by not good, okay, nach. And nach then is a kind of release because, phew, now, well, you just need to get Gerichtsverfahren right. But after that, it's plain sailing and the translation is perfectly in place. And the whole thing ends with a beautiful, sweeping reading of guilty, found guilty was read about 5 times because that has to be remembered. In German you have the main verb coming at the end, so found guilty was revisited 5 times in the process of doing this one short sentence. But now the translator is already far into the next sentence. Here is where everything is done. And let me come then finally to contextualizing what we do in terms of the kind of scientific disciplines that I think our way of doing translation process research is related to closely associated disciplines. There is neurophysiology or neurolinguistics, and they are interested in measuring electrical activity in the brain mainly. We have been focusing on the green stuff here, on behavioral cognitive elements. So we do the selective behavioral observations of eye movements and finger movements. And we triangulate this information with cued retrospective qualitative data spoken by the participants themselves. And all of this is based on a few very simple assumptions that we fortunately share with other sciences, like cognitive psychology, for instance, that what we record on the outside correlates somehow with the inside, that there is this correlation, that low-level outside data also probabilistically co-vary with the information that is being processed. And that we can build from our low-level data bottom up to higher-level conclusions about information processing. In other words, we see this correlation between the mind, the brain, and behavior. So the mind is this wonderful thing that we can't really say what is, which is everything, all the fantastic ideas and thoughts and emotions and so on that we experience. The brain is the meat inside our skull that doctors cut into and that where we can measure electrical activity, and then the behavior that we can observe. And this is paralleled by a problem and a processing effort in a processing effort in the brain, measurable by the in different ways, fMRI and so on, and duration. So there is this correlation between duration and in behavior and the rest. And then we advocate multi-methodology very strongly. We think that we can build stronger hypotheses if we use more methods and get converging ideas from the data. So many thanks, and if you have questions, you're welcome to asking them. I haven't talked very much. I haven't talked about interpreting, and I feel that I ought to have said more about that, perhaps, Lucia, because you're interested very much in speed phenomena also, in interpreting. And of course, I think, having worked with translation, I think translation is so derivative of interpreting that I ought to have given interpreting much more attention, because obviously speech is primary in relation to writing, don't you think? I mean, in evolutionary terms, speech is primary. We learn to speak. We can speak very well even if we can't write. I mean, writing is so secondary. And translation, therefore, written translation, is really very secondary and very abstract. It takes a lot of training and skill to be able to activate the kind of mental images from a text that we get much more easily from speech. I think speech is also far more information rich in the sense that we derive information from voice quality, from hesitations also in speech, from all the prosodic features, stress, intonation, and so on, that is not represented in written text. So we have to construct that, which is why some people enjoy audiobooks much more than reading books. And you can buy, I mean, now you get a lot of audiobooks. Why? Because a good reading of a novel, for instance, is an interpretation. And you get the information that you need to bring to the text yourself if you are reading. You get that from the voice of the reader in an audiobook. So I see two that I know are into the interpreting world, and there may be more. Are you more? Are you more into interpreting than into translation? Because Lucia and I were talking a little bit about how some of this methodology could be applied to interpreting, and of course, the latest in eye tracking is that you can simply put on a pair of glasses, and the glasses have at least 3 cameras. So there's one forward camera which records the visual field, and then 2 backward on the inside of the glasses which record where your eyes are targeted within the visual field. And one option would be, if you were interested in using the technology to study interpreting, let's say conference interpreting in a booth, you might want to know how much an interpreter is looking at the speaker, how much an interpreter is looking at the audience, how much the interpreter is looking at the speaker's visuals, how much the interpreter is looking at the text that may have been presented. You might want to know to what extent the text is related to what is being spoken also, and how this is prioritized by or managed by the interpreter. Obviously, what is spoken is what has got to be interpreted. You might want to know if the interpreter takes notes and looks at the notes, or associates with somebody else in the booth, and so on. There's a lot of information that I think you could get, and it would be very interesting. And you would get the speed data that you are interested in also, with all the information about décalage and stuff. And of course, we've stolen a little bit from interpreting studies. This idea of décalage is what is the time lag between the time when a speaker speaks a word or a phrase and the time that the interpreter presents the interpretation of that. And in translation, similarly, we have introduced the I key delay, so that we have 2 measures, in fact. When is a word first seen before it gets translated, and when is it last seen before it gets translated? Because what we find very often, and in fact typically, is that, and I think this is typical of trained and good translation behavior, is that reading goes on until there is this translatable unit, until that has been identified. Okay, then typing begins with reference back to elements in the translatable unit. So you get reading, okay, now I have my unit, then typing begins, then you make reference very frequently. So you have an early visit, if you like, gaze visit to what gets translated, and then you have late visits, and quite frequent, which is part of the monitoring of the activity that goes on. You see the same in sight translation data, where you might want to ask, why is it that there's more visual attention to the source text in sight translation than in reading for comprehension, for instance? Because if you've comprehended, couldn't you just close your eyes and do the sight translation? You could, I suppose, but you don't, because you monitor how far your spoken production of the sight translation has got in relation to the words of the source text. So sometimes you do simultaneous with text, don't you? Or maybe you are too skilled to ever want to refer to the text. You don't need to do that. But I know that at some level, some interpreters are interested in simultaneous with text or simultaneous without text. Yeah, maybe the experimental site translation situation is too far removed from what a really professional interpreter will do in that situation. But can I ask you, do you see applications in your own research for some of the technologies that we have been using, that I've been talking about?
Personally, it's quite crowded because I'm more in sociological methods of translation. So, for the moment, it's very far.
Sociology of the translator, translator status.
Yeah, actually. Sorry, I forgot our colleagues. Yeah, it's more about how translation is used to do something, so in a political action.
Yeah.
So the whole idea just to ask, well, to do interviews and to ask, okay, you have to produce a text, a multilingual text. How do you do that? Why would you use translation here and not there? All this kind of things. So I think that it could be very interesting to look at how these texts are actually produced.
Yeah.
But I see it from a point of view more through observation, I have to say.
This is really interesting, and this is one thing that we've been criticized for more and more, in fact, recently, because people have said we get claustrophobic about trying to figure out what goes on in the mind. We want to know what goes on in the workplace, for instance, in the real world, outside. And so I think this is a trend that research is moving out of the lab, if you like, into the workplace. Using maybe not only sociological methods, but ethnographic methods, fieldwork type interview studies, where, yeah, very much anthropological methodology, in a way that you go out there among the natives into the wild, in the workplace, I mean, you sit down with a recorder, but even there, I would say, technology begins to enter into this kind of research also, because it gets less and less intrusive. You don't have to fit electrodes to the heads of translators. You can install software that will log information from their computers. You can even now, well, maybe this is a little intrusive, but I was reading about a jacket that you can wear. You wear a jacket and it will give you all kinds of physiological information about galvanic activity on the skin, for instance, if you're nervous, if you're sweating, your heart rate, your oxygen levels in the blood and stuff. All kinds of readings, physiological readings about people. And it's all from this jacket or from a kind of glove or whatever. So it's there. It might make people nervous, probably would. But some of these experimental methods, I'm saying, can be introduced. Cameras that you didn't know were there, but of course this is unethical in research, not to tell participants if they are being monitored in a certain way. But, I mean, yes, you can use straightforward ethnographic methods, and this would be fine, and this is very interesting. And what is interesting, moreover, is socio-cognition, if you like. That is, you become interested in the way in which cognition is affected from your environment, not just from the text, but from the entire environment, the way in which you relate socially to people in the same room, for instance, the way you relate to room temperature, to ergonomics. Ergonomics is big also in your area. How do I sit? Am I comfortable with my keyboard and my viewing distance from the screen and all of these things? So you're onto an interesting extension, I would say, of, you've said it was very far removed from here, but I see a connection. On the cognitive side, and potentially, but I don't get the impression that you are all that interested in fitting your translators with too many goggles and jackets and so on. Any other questions or comments? Feel free.
Well, I just wanted to say that, in fact, yes, that could be used, in the field of conference interpreting studies, because, for example, we could analyze the impact of speed on eye movements, for example, when you have the text on how where the interpreter is looking depending on the speed. For example, if you are interpreting with the text, if the reading is similar to when you are interpreting a 120 words per minute speech, or 200 words per minute speech. I think there is an application in the field of conference interpreting. Yeah.
It's certainly possible. And one type of interpreting that could be studied in this method. It gets very complicated if you want to study interpreting that goes on in some other areas. In areas of conflict, for instance, how would you, if you were an interpreter in a war zone, in a refugee camp, so you wouldn't be too welcome with a camera, I don't think, or with an eye tracker and so on. And nevertheless, we want to be able to study how interpreting and translation can function in some of these environments that I think are incredibly important right now as we speak in the world. This is something I hope that we can all agree in trying to make the world know how important interpreting and translation are in the field of diplomacy, if you like, in the field of mediating understanding among very different people, very vulnerable people in immigration situations. So this is why I think there's a lot of interest currently in community interpreting. But what it illustrates for me is the vital importance of our field. What is it that makes us capable of mediating meaning, meaning with full emotion and everything across languages? I think this is more important now in the world than ever. So let that be my final words, perhaps, today. Thank you very much for coming and being here.